All right, so section 3.5 focuses on slope, which is a rate of change. Specifically, it's the vertical change over the horizontal change. And there's a couple things we kind of want to add here. Vertical change over horizontal change, or as you probably know from your high school algebra class, rise over run. This is the way we're going to find slope graphically. This is the graphically way to find slope. You'll need to know how to do that. Algebraically, we're going to use this formula. There's advantages to both. Sometimes algebraically is the quicker way to do it. Sometimes graphically is the quicker way to do it. And if you can't read that formula, that says y sub 2, it's a subscript, minus y sub 1 divided by x2 minus x1. It's not that important, the numbers, but what's important is the y's go on top and you subtract them, the x's go on the bottom and you subtract them. And then finally, this is just a quick little tip. You read a line like a book, left to right. So from left to right, if you see a line starting down here and rising from left to right, that is an example of a positive slope. So if you do your calculations for a line like this and you get a negative slope, you'll know you've calculated incorrectly. And then likewise, from left to right, this line is trending downhill. So this line should give you a negative slope. So if you do the calculations and the slope is not negative, you know you've made a mistake if it's going downhill like that. So let's go through just a couple examples, and we're going to find the slope using the graph and using the formula. So graphically and algebraically. So we want to find the slope of the line containing those 2 points. So graph negative 6, 1 and graph 2, negative 5. Typically, a problem like this where they haven't graphed it for you already, I would say algebraically is the better way to do it. Because you don't have to have a picture to use the formula. All right, so we're going to find the slope using the graph. The first thing we want to notice, this line is going downhill from left to right. So from left to right, it's trending down, so that tells us our slope should be a negative number. No matter which way we calculate it, the slope should be a negative number. So now we're going to do this graphically, and we're going to do the vertical change from this point. So I'm going to kind of draw a right triangle, and I'm going to go down until I get to the same level as that other pink dot. So that vertical change in this case is 1, 2, 3, 4, 5, 6. You might say negative 6 since we went down 6, and when we go down 6, the y coordinate changes to negative. You certainly can do that. And why don't we do that? Negative 6. So that is our vertical change. And then our horizontal change. So starting from this point, we're just going to kind of finish off this little right triangle and stop when we get to the point and count those unit blocks. Starting here, 1, 2, 3, 4, 5, 6, 7, 8. So we went right 8. We would typically write that as a positive 8 because when we move in the x direction to the right, that's a positive number. So negative 6 over 8 is the slope. We can divide the top number and the bottom number by 2 to reduce that fraction. So the slope is negative 3/4. Technically, you can also write it as 3 over negative 4. Because you just as easily could go backwards. So if we started from this pink dot and went left 8, we could say, oh, well, that's a negative 8. And then we would say we're going up 6, and we get a positive 6. So it just depends on how you read the graph from left to right, but both of those are acceptable. We always want to write our slope as a fraction unless otherwise directed. Now we're going to solve it algebraically. So we're going to do y2 minus y1 over x2 minus x1. So our points in this problem are -6, 1, and 2, -5. It doesn't matter which ordered pair is x1, y1. We're just going to call this first ordered pair that I wrote down my x1 and my y1, my first x and my first y, which would mean this is my second y and my second x. But again, we could reverse that order just as easy. It's also important to know that if you accidentally reverse the slope formula and you do y1 minus y2 over x1 minus x2, you're going to get the same ultimate slope. It goes back to this idea that we just looked at of these two different equivalent fractions. It's the same idea. So we're going to use the slope formula in black though. So we're going to do y2, which is -5, minus y1, which is 1. Remember, there's always a subtraction sign in the middle. So that's our y's. And on the bottom, we're going to do x2 minus x1. So we've got a minus a -6, which we know a double negative, just like in English, a double negative negates itself, and that becomes a +6. So -5 minus 1 is -6. 2 plus 6 is 8. And as you can see, the exact same fraction that we got using the graphing method. I would encourage you to pause the video and try this example. So again, I'm going to do this graphically first. And again, the thing you should notice, this graph is going uphill from left to right. So that means the slope here is going to be a positive number. So I always like to do rise first and then run second. So we're going to do vertical change over horizontal. Doesn't matter which one you do first. But my vertical change, I'm going to go up from that point and stop when I get level with the other pink dot. And then count my squares. I'm not going to count the first pink dot. There's 1, 2, 3, 4, 5, 6. And then divide it by the horizontal change. So I'm not going to count that first dot. 1, 2, 3, 4. So the slope is 6/4. Both of those numbers are even. So our slope is +3 over +2. And again, if you went the other way in this problem, you may have ended up with -3 over -2. And we know that a negative divided by a negative ends up being a positive. So it doesn't matter which point you started with in this problem. And then finally, algebraically, we're going to do y2 minus y1 over x2 minus x1. So choose your point. Again, always just whatever point I write down first, I'm going to make that my first x and my first y, and make the second point my second x and my second y. And then we're just going to substitute here, being careful when we have lots of negatives. So y2 is 1 minus y1, which is -5. So we've got that double negative again. That'll happen a lot. Divided by x2 minus x1. So the double negative becomes positive. 6/4. We get the same answer. 3/2. Real quickly, horizontal lines. Have a slope of 0. And that's because, what is the vertical change in this problem? The vertical change is 0. The horizontal change, well, it depends on which 2 points you picked, but it really doesn't matter what the horizontal change is because 0 divided by anything is 0. So horizontal lines have no slope. Think of it, the example I always give is think of it as if you were walking this hill. It'd be really, really easy because there's a nice 0 steady slope there. Inversely, vertical lines, think about what the vertical change is in this problem. Or really, let's not think about the vertical change. What's the horizontal change? So again, if you just pick any 2 points on that line, is there any horizontal change between those 2 points? There is not. So that tells me the horizontal change is 0, and you cannot divide a number by 0. So vertical lines have a slope of undefined. And using that same example, think about trying to walk this hill, and it's going to be a free fall. You cannot walk a vertical line. So undefined slope for vertical lines, slope of 0 for horizontal lines. Pause the video. I'm going to show the answer here in just a few seconds for this last example, and that'll be it. So my pen has stopped working here right at the end, but the slope should be 5/2. When you do it algebraically, you should end up getting -5 over -2, and a negative divided by a negative ends up giving you this same +5/2 as a slope.